All right, ready to dive into some serious mind-bending stuff.
Oh, absolutely. Always up for a challenge.
Today, it's quantum computing.
Not just the hype, though, right?
Exactly. We're going way past that. We've got a BuyPoint analysis of 4 companies that are pushing the limits of what's even possible.
Okay, lay it on me. Who are we talking about?
IonQ, D-Wave Quantum, Quantum Computing Inc., and Rigetti Computing.
Oh, wow. That's a fascinating mix. Each one's coming at it from a totally different angle.
It's like they're all trying to climb Mount Quantum, but taking totally different paths.
I like that. So before we get lost in the weeds, can you give us a quick overview of those paths? What are the main approaches in quantum computing these days?
Sure. So you've got companies like IonQ and Rigetti. They're all about gate-based quantum computing.
Which is, remind me again.
It's the approach that's closest to how our regular computers work, using logic gates.
Ah, right, but instead of bits.
It's all about QUBTs, short for quantum bits.
Okay, yeah. Qubits. But why are they so special? Just a fancy name or what?
Definitely not just a fancy name. Regular bits, it's either a 0 or a 1, like a light switch on or off.
Makes sense.
But a QUBT, thanks to the crazy world of quantum mechanics, it can be both 0 and 1 at the same time.
Whoa. How is that even possible?
Think of it like a dimmer switch. Not just on or off, but every level of brightness in between. That's superposition.
Okay, I'm starting to see why people are freaking out about this.
And that unlocks a whole new level of computing power. So gate-based quantum computing is using these qubits to do calculations. What about that other path you mentioned?
Right, that's quantum annealing, where D-wave comes in. Imagine you have a computer that's not trying to do everything, but it's really, really good at one specific type of problem.
Like what? Give me an example.
Finding the absolute best solution out of, like, a million possibilities.
So like finding the best way to deliver packages or picking stocks, that kind of thing.
Exactly, stuff like that. Quantum annealing is amazing for those kinds of problems. So the big question now is, which path is going to lead to the biggest breakthroughs?
That is the question. Well, let's start with IonQ, ticker symbol IONQ. They're using trapped ion technology, which sounds pretty sci-fi, to be honest.
Yeah, it does, doesn't it? Basically, they use these things called ion traps. They use electromagnetic fields to hold individual atoms, which are the ions, in a very precise spot.
Okay.
And then they use lasers to cool those ions down, super low temperatures, which is really important for making them act in a quantum way. And those trapped ions become the qubits. IonQ thinks this is the way to get the best quality qubits out there.
High quality meaning?
Well, they're super stable,
Mm-hmm.
and they can hold on to that fragile quantum state for longer.
Ah, so it's not just about having a bunch of qubits, it's about having really good ones.
Yep, quality over quantity, right?
Right.
And the longer a qubit stays coherent, the more complex stuff you can do with it.
Makes sense.
So IonQ's betting that trapped ions are the key to bigger and more powerful quantum computers down the line.
And they were the first pure play quantum computing company on the New York Stock Exchange, which is a big deal, right?
Huge deal. That was back in 2021.
Wow, 2021. That's a while ago now. How's their stock been doing?
Well, it's been kind of a roller coaster, to be honest. Typical for a brand new market like this. But the fact that they're publicly traded at all means that quantum computing is getting serious.
But come on, there have got to be downsides.
Oh, absolutely. Like everyone in the gate-based world, their biggest challenge is scaling up. Building a system with a handful of trapped ions is one thing, but getting to thousands or even millions, that's crazy difficult.
So, yeah, high-quality qubits, but can they make enough of them to compete?
Exactly. That's the race right now. Who can get the most qubits while keeping them top-notch?
Okay, so we've got IonQ with their trapped ion tech. Let's move on to D-Wave Quantum, ticker symbol QBTS. They're the quantum annealing folks, right?
That's them. And the crazy thing is, they've already got systems you can buy. While everyone else is still in the lab, D-Wave's out there selling. Their quantum annealers are solving real-world problems today.
So they're actually putting it into practice, not just talking about it.
Totally. But remember, it's not magic. Quantum annealing isn't replacing computers as we know them. It's more like a specialized tool, really good for specific tasks.
Right, like those optimization problems we talked about earlier.
Exactly. It's like you wouldn't use a hammer to screw in a light bulb, would you?
No way.
Right. Each tool has its job. D-Wave's annealers are built for optimization, and they're killing it.
Okay, that makes sense. But there must be limits, right? Are there problems that quantum annealing just can't handle?
Of course. It's great at finding the best solution out of a bunch of possibilities. That's its thing. But it's not as flexible as gate-based computing. Can't handle the same range of calculations.
So if I want to crack codes or simulate molecules, I need a gate-based system.
Probably, yeah. Though there is some overlap. Some researchers are using annealing for simulations, but it's not its main gig right now.
So D-Wave has found their niche, but they've got competition from companies like IonQ that want to build the all-purpose quantum computer.
Totally. It's a race. Speaking of, how's D-Wave's stock compared to IonQ? Are investors as excited?
Good question.
Well, both have been up and down like crazy, which isn't surprising. It's such a new field. Investors are just trying to figure out who the winners will be. D-Wave's stock has jumped when they announce a new partnership or hit a milestone, but then it drops when people worry about the whole market or how quickly quantum computing is actually being adopted.
So it's a roller coaster for everyone involved?
Pretty much.
Oh.
But remember, we're still in the super early days of all this. It's like investing in the internet back in the 90s.
Ah, the wild west of the internet.
Exactly. Tons of potential, but it's going to take time.
Okay, so that's the hardware side of things. But what about the software? That's where Quantum Computing Inc. comes in, right? Ticker symbol QUBT.
Yep. They're all about making quantum computing accessible, even for businesses that can't build or buy their own quantum computer.
So how do they do that?
They build what they call quantum-ready software. It can run on regular computers today, but it's designed to work on quantum computers when those become more powerful.
So it's like future-proofing your business for the quantum age.
Exactly. It lets companies experiment with quantum algorithms now, without having to wait for the hardware to catch up.
Clever. It's like building the software for a house before you even pour the foundation.
That's a good way to put it. And it means QUBT can reach a way bigger market.
But how do they make money if it runs on regular computers? It seems like they're giving away the secret sauce before the meal is even cooked.
Not giving it away, more like a subscription service. You pay to access their library of quantum algorithms and tools. And when quantum computers become more common, their software will be ready to go, giving them a head start.
So they're like the bridge between the classical and quantum worlds.
Exactly. And investors are paying attention. Their stock, like everyone else, has been up and down, but they get spikes when they announce new partnerships or product launches.
Definitely a company to watch then, especially if you think software will be just as important as the hardware in this whole quantum revolution.
Couldn't agree more.
Okay, so we've got IonQ with trapped ions, D-Wave with quantum annealing, and QUBT with their software. That leaves us with Rigetti Computing, ticker symbol RGTI. They're the full stack company, right? What does that even mean in quantum speak?
It means they do everything. They design and build the quantum processors, but they also do the software and control systems that make it all work. They're not building a piece of the puzzle, they're building the whole thing.
Ambitious.
For sure.
Yeah.
And that comes with its own set of problems.
Like what? Isn't doing everything good?
Well, you need a ton of expertise and resources. Top engineers, physicists, computer scientists, everybody. And it's tough to be the best at everything. You might end up being good at a lot of things, but not great at one specific thing.
So they're spreading themselves thin, maybe losing focus.
It's a risk. But it could also be a huge advantage. By controlling everything, they can make sure each part works perfectly with the others. Their software will be perfectly tuned to their hardware, which could give them a performance edge.
Interesting. So they're betting that being super integrated is what will make them win.
Exactly.
So what kind of technology are they using for their processors?
Superconducting transmon qubits. It's another one of the leading approaches right now.
Transmon qubits. Those are different from the trapped ions that IonQ uses, right?
Totally different. Instead of trapping atoms, transmon qubits are made from superconducting circuits. Imagine tiny loops of wire cooled down to almost absolute zero.
Whoa, why so cold?
Because at those crazy low temperatures, electrons start acting weird. They pair up and flow without any resistance. It's called superconductivity.
Okay.
And in that state, the circuits start showing those quantum properties, like superposition and entanglement.
So the superconductivity unlocks the quantumness.
You got it. It's a crazy phenomena. And it's the basis for a lot of quantum computing approaches, including Rigetti's.
So how are they doing compared to the others? Is their performance as good?
Well, their stock has been all over the place, just like the rest of the quantum computing market. Lots of uncertainty, lots of ups and downs. They had some wins, big partnerships, government contracts, but also delays and problems scaling their tech.
So mixed bag, but still worth keeping an eye on.
Definitely. They're really pushing the limits, and it's exciting to see how this full stack approach plays out.
Okay, well, I'm definitely feeling a little overwhelmed with all this quantum information. in a good way.
Yeah, it's a lot to take in.
It's like peeking into the future. But before we get lost in the possibilities, let's take a quick break. Then we'll come back and talk about how quantum computing could actually change different industries.
This sounds good to me. All right, ready to dive back in?
Oh yeah. My brain's still buzzing from our last conversation, but hit me with more. We've covered IonQ, D-Wave Quantum, Quantum Computing Inc., and Rigetti Computing. 4 companies, all with their own take on building this crazy quantum future. But I'm curious, what does it actually mean for, regular people? How's this going to change our lives?
That's the million-dollar question, right? And honestly, we're only just starting to figure that out. But even now, we can see glimpses of how powerful this tech could be.
Give me some examples. Where is quantum computing going to have the biggest impact?
One area everyone's excited about is drug discovery and materials science. Imagine designing drugs or materials at the molecular level, testing out millions of possibilities before even stepping foot in a lab.
So instead of that long, expensive trial and error process we have now, you could use quantum computers to design drugs that are more effective, fewer side effects, and even personalized to your genes.
Exactly. That's the dream. And it's getting closer every day. And it's not just drugs. We could design entirely new materials, things that are lighter, stronger, better conductors, maybe even self-healing materials. Crazy stuff.
And now that's straight out of a sci-fi movie. What other areas could quantum computing disrupt?
Well, anything that involves really tough optimization problems, like we talked about with D-Wave and their quantum annealers. Logistics, finance, all that.
Right, figuring out the best delivery routes, making the most of your investments, but I bet it goes way beyond that.
Oh, for sure. Think traffic in cities, energy grids, how we manage supply chains. All those systems have tons of data, tons of moving parts. It's almost impossible to optimize using regular computers. But with quantum computing, we might find solutions that are way more efficient, saving time, money, resources.
So quantum computers could mean smarter cities, tougher energy grids, and more productive businesses.
Exactly. And that's just the start. There's a whole field called quantum machine learning. It's using quantum algorithms to build even more powerful AI.
AI is already changing the world so fast, and now we're talking about making it even stronger with quantum. It's kind of scary, honestly.
I get it, it's a lot. It's important to remember that anything this powerful has risks as well as benefits. That's why these conversations are so important. We have to think carefully about how we use quantum computing so that it benefits everyone.
And speaking of risks, what about cybersecurity? I've heard that quantum computers could break the encryption we use to protect our online data. That's a bit terrifying, isn't it?
Yeah, that's a real concern. A lot of the encryption we use today relies on math problems that are super hard for normal computers to solve.
Right.
But a powerful enough quantum computer could crack them.
So what are we doing about that? Are we just sitting ducks waiting for the quantum apocalypse?
No, not at all. There's a whole field called post-quantum cryptography. It's all about developing new encryption that can stand up to both regular and quantum computers. And governments and businesses are taking it seriously, investing in research to make sure our data stays safe this quantum future.
Phew, that's good to hear. So there are challenges, definitely risks with quantum computing, but there are also brilliant people working to make sure we use this power for good.
Absolutely. And that's what makes this so exciting. It's not just about faster computers. It's about pushing the limits of what we know, exploring the universe in a whole new way, and using those discoveries to build a better future.
Well, I'm definitely feeling hopeful after hearing that. You've painted a pretty amazing picture of what quantum computing could do. But let's bring it back to those 4 companies we talked about. What are the specific challenges and opportunities they face in this crazy quantum race? We know they're all taking different paths up Mount Quantum. Who do you think has the best chance of reaching the summit first?
That's a tough one. No crystal ball here. But we can look at their progress and the overall trends to get some clues.
Perfect. Let's do it. Last time we were talking about Rigetti Computing and their full stack approach. What are some of the big challenges they'll need to overcome to be successful?
I'd say the biggest one for any quantum company, Rigetti included, is just building a quantum computer that's reliable and scalable. It's not just about making a few qubits in a lab. It's about creating a system with hundreds, thousands of qubits that can hold on to their quantum state long enough to do serious calculations. And it all has to be cost-effective and able to grow to meet the demand for quantum computing power.
So it's like building the first spaceship to Mars, a massive engineering feat.
Great analogy.
Mm.
It requires pushing the limits of what we can do with materials, precision engineering, control systems, and Rigetti, because they're doing the full stack, they're basically trying to build every piece of that spaceship themselves.
Which, like we talked about before, is both risky and potentially awesome. So what are some things they need to focus on to make this work?
One big one is qubit quality. They have to keep making their qubits better, get them to hold their quantum state for longer so they can do more complex calculations, and they need to make them more accurate, reduce the errors, which are a big problem right now.
So again, it's not just about the number of qubits. It's about having really good ones that last and are precise.
Exactly, and that's where the material science and engineering skills come in. Rigetti is always trying new materials, new ways to build these qubits to make them perform better.
And what about their software? We know they're building their own, but do they really need to? Couldn't they just use software built by other companies?
They could, but having the hardware and software perfectly matched is a big advantage in the quantum world. By building their own software, Rigetti can make sure it works perfectly with their hardware, squeezing out every bit of performance.
It's like Apple designing their own chips for their iPhones. They control everything, so they can make it all work together smoothly.
Perfect analogy. And it's a strategy that could really pay off for Rigetti in the long run, especially if they can pull off this whole full stack thing.
Okay, so challenges, check. But what about opportunities? What could really launch Rigetti to the front of the pack?
One big one is cloud-based quantum computing. More and more businesses and researchers want to try quantum computing, but don't want to build their own expensive systems. They want to access it through the cloud, like we do with regular computing.
Right, like how we use Amazon or Microsoft for cloud storage and services. Now we'll have that for quantum computing too.
Exactly. And Rigetti's in a great position to be a leader in that. They've already launched their own cloud platform, giving people access to their processors and software. And they're partnering with big companies and research groups to make their technology available to even more people.
So they're building the whole quantum package, hardware, software, cloud access. Smart.
Definitely. In a field this complex and fast-moving, being able to offer the complete solution is a big advantage. It lets them attract all sorts of users, from researchers studying fundamental physics to businesses developing new products. And that diversity of users could actually speed up the development of new quantum algorithms and applications, creating a win-win for everyone.
Okay, so Rigetti's got a lot going for them. Let's go back to IonQ, the company with the trapped ion technology. They made a big splash going public, but how are they holding up against the competition? What are their strengths and weaknesses?
Well, their biggest strength is still the quality of their trapped ion qubits. They're some of the best in the business, with long coherence times and low error rates. That's super important for doing complex calculations. And they've made good progress in scaling up, recently announcing a new generation of processors with even more qubits and better performance.
Sounds like they're ticking the boxes for quality and scalability, but what are the challenges they're facing?
Their technology is complex. Trapped ion computers need sophisticated laser systems and vacuum chambers to control those ions. That's expensive and hard to scale up to lots of qubits. And they've got competition from other approaches, like those superconducting transmon qubits, which are easier to make and scale.
So it's a trade-off. High-quality qubits, but maybe harder to scale up quickly. Can they keep up with the pace in other areas of quantum computing?
That's the key question. They know the pressure's on, and they're putting a lot of resources into research and development to stay ahead. They've also been smart about making partnerships with big tech companies like Amazon and Microsoft, offering their technology through cloud platforms.
So they're playing to their strengths and adapting to the changing market.
Exactly. Being able to adapt is going to be crucial for any quantum computing company to survive, let alone thrive. It's such a dynamic field, things are changing constantly. The companies that can stay flexible and innovative are the ones that will win in the end.
Okay, so IonQ's got their high-quality qubits and smart partnerships. What about D-Wave Quantum, the quantum annealing specialists? They've been around a while, they've got systems you can buy right now, but what's their future look like? Can they stay ahead in quantum annealing, or will the other companies catch up?
Great question. D-Wave has definitely established themselves in the quantum annealing market. They've got a solid track record building and delivering systems that can handle specific types of problems, and they've got a growing list of customers using their tech to get ahead in their industries.
So they're not just a research project, they're a real company with real customers getting real results. That's got to be a big plus, right?
Definitely gives them an edge. But they've got challenges too. Some people see quantum annealing as less capable compared to gate-based quantum computing. It's great for certain types of optimization, but it's not as flexible as those gate-based systems that can handle a wider range of tasks.
So they're like the specialists, while companies like IonQ and Rigetti are trying to be more like general
Good
practitioners.
way to put it. And while there's definitely a need for specialists, the question is if that market is big enough for D-Wave to keep growing in the long run.
So they have to convince potential customers that quantum annealing is the right tool for the job, even if it's not the most versatile one.
Exactly. And they're doing that by focusing on industries where quantum annealing is already proving its worth. Things like logistics, finance, materials science, and they're always researching and developing, trying to make their systems even more powerful and capable.
Smart move. Okay, we've talked a lot about the hardware, but what about the software side? Earlier, we talked about Quantum Computing Inc., or QUBT, and their quantum-ready software. How are they doing in this rapidly changing market? Are they really bridging the gap between the classical and quantum worlds?
They're doing really well, actually. They've been steadily building and improving their software platform, which is all about helping businesses explore quantum computing without having to buy their own quantum hardware. They've got partnerships with some big names, offering their algorithms and tools through the cloud, and they're always adding new algorithms and applications, making their platform more useful for more people.
So they're like the neutral party in the quantum world. They don't care who wins the hardware race. They just want to give everyone a place to experiment with quantum, no what kind of hardware they end up using.
That's a great way to put it. And it's a smart strategy. It means they can reach a much bigger market than the companies focused only on hardware. They're building that bridge between the computers we use today and the quantum computers of tomorrow.
And that bridge is going to be more and more important as quantum computing becomes more mainstream. They could be the key for businesses that not to use quantum computing, but don't have the knowledge or resources to build it themselves.
Absolutely. That's why I think QUBT is a company to watch.
Yeah.
They might not be building the most impressive quantum computers, but they're playing a crucial role in making this technology accessible and practical for everyone.
Well, we've covered a lot today. Trapped ions, superconducting qubits, quantum algorithms, cloud platforms. It's mind-blowing stuff, and it's changing so fast. But with all this excitement and progress, one question keeps coming back to me. What does it all mean for humanity? What are the long-term consequences of this quantum revolution that's happening right in front of us?
That's a deep question. And it's one we'll be wrestling with for a long time as quantum computing becomes more powerful and more integrated into our lives. I think it's safe to say that this technology has the potential to be as transformative as the internet or even electricity. It could reshape entire industries, create new jobs and opportunities, and fundamentally change how we live, work, and interact with the world.
But with great power comes great responsibility, right? We talked about cybersecurity and needing new encryption, but what other potential downsides should we be thinking about?
One concern is job displacement. As quantum computers get better, they could automate tasks that humans currently do, potentially leading to job losses in certain sectors.
So it's like the concerns we have about AI and automation, but on an even larger scale.
Exactly. And that's something we need to address as a society. How do we prepare people for the jobs of the future? How do we ensure that everyone benefits from quantum computing, not just a select few?
Big questions, for sure. What other ethical concerns are people raising about quantum computing?
Another one is bias and discrimination. Like any technology, quantum computing can be used for good or bad. If the data used to train quantum algorithms is biased, the results could reinforce or even amplify existing inequalities.
So it's not just about the technology itself, it's about how we use it. The human choices are just as important as the technical advancements.
Absolutely. We have to think about the ethical implications of quantum computing right from the start, making sure it's used to benefit everyone, not just a privileged few.
Well, I think that's a great note to end this part of our conversation on. We've explored the amazing potential of quantum computing, the challenges and opportunities facing these companies, and the ethical questions we need to address. It's a journey that's just beginning, and we don't know exactly where it's going to lead, but it's going to be incredible to watch.
Couldn't agree more. Such an exciting time to be following this field.
Okay, we've definitely given our listeners a lot to digest here. Different approaches, companies, potential benefits, and the ethical stuff too. It's a lot. But before we wrap up this whole quantum journey, I'd love to get your big picture take. What trends are you seeing out there, and where do you think this technology is headed?
You know, one thing that's really clear is how quantum computing is starting to merge with other cutting-edge tech.
Mm.
Things like AI, cloud computing, We're seeing a ton of research on combining these things, trying to create even more powerful solutions.
So it's not enough to just build a better quantum computer. We need a whole ecosystem where it can work together with other technologies, really amplifying its impact.
Exactly. And I think that's where we're going to see some truly game-changing breakthroughs.
Mm.
Imagine AI that's powered by quantum computers, able to tackle problems that are just impossible for regular computers to solve. Or cloud platforms that give anyone access to the latest quantum computing power right at their fingertips.
It's hard to even imagine what that world will look like. What about the speed of all this? We've seen a lot of progress lately, but can it keep going at this pace? When will quantum computing become, something we use every day?
It's tough to say for sure. Quantum computing is still pretty young, and there are definitely big challenges ahead. But I'm optimistic. I think we'll keep seeing rapid progress thanks to more investment, more collaboration between researchers and companies, and the development of new quantum architectures and algorithms.
So it's not a matter of if, but when quantum computing goes mainstream.
That's my bet. It's just a matter of time. I think we'll see real adoption in certain industries within the next decade or two. Drug discovery, material science, finance, tactitive. Those fields are ready for what quantum computing can do, and we're already seeing early examples of its impact.
So if I'm a student listening right now thinking about my future, should I be looking into quantum computing as a career?
Absolutely. If you want to be at the forefront of technology, working on something that could literally change the world, quantum computing is the place to be. The demand for talented people in this field is only going to increase.
Great advice. But what about those of us who aren't planning to become quantum physicists? How can we keep up with all this, understand what's happening?
There are so many great resources out there, articles, videos, even online courses that explain the basics of quantum computing in a way that anyone can understand. And there are conferences and events where you can learn from the experts and connect with other people who are interested in this stuff.
So it's not just for scientists and engineers, it's something everyone can explore and appreciate.
Absolutely. Quantum computing is fascinating. It raises big questions about reality and what we can know. It's full of wonder and possibility.
Well, you've definitely done an amazing job of sharing that wonder and possibility with us today. You've given us a glimpse into this incredible future where quantum computers could solve some of humanity's toughest problems and unlock new levels of creativity and innovation. It's inspiring.
Well, thank you. I'm glad you found it inspiring. I'll encourage everyone to keep learning, keep exploring this amazing world of quantum computing. The future is quantum, and it's coming fast.
I love that. The future is quantum. And on that note, we've reached the end of our deep dive into this incredible field. But remember, this is just the beginning. I hope you'll dive deeper into the information we've provided, keep track of these companies, and most importantly, keep asking questions and imagining what's possible. The quantum world is full of mysteries and opportunities, just waiting for us to discover them. Until next time, keep exploring.